All right, I'm going to talk about history and advancements. I'm going to hand it over to Jason, who's going to talk about applications and case studies, and then Jeffrey's going to wrap it up with adoption and conclusions. History. I'll come back to the meaning of this picture in a moment. LED technology. Solar lights use LED. Solar aviation lights use LED technology as their light source, and the reason for this is because they're very efficient, as we've been talking about. And solar energy is light from the sun, the most abundant light source on Earth. Due to the development of technology such as the solar cell, we are able to collect this energy and convert it into useful electricity. Solar power is an intermittent energy source. Therefore, energy storage is important. Sunlight must be absorbed when available and stored for later use. Rechargeable batteries are used to store this excess energy. When we size solar power supplies, there's two primary things we're concerned about. The first is autonomy. That's related to the battery size, how long the light will operate with no recharge. And the second is the recharge rate, because the recharge rate dictates the solar panel size and ensures that there always is a useful amount of energy left to make sure the light can operate. Solar technology has been used in the marine industry for 20 years. It's widely adopted, reliable power source for aids to navigation to ensure safe vessel guidance. And as you can see in this IEA guideline, which is similar to the marine of our FAA and ICAO, solar adoption as a power supply is highly recommended. It's recommended for remote sites, no easy access, medium and low voltage situations, extreme temperatures, buoys, and major floating aids. The other interesting fact about this table is the fact that the life expectancy is 20 years. In the marine industry, the extreme environments that these solar power supplies are put in is very high salt, fog, water, extreme temperatures, and they last for 20 years. Solar was adopted as a power supply for aviation lights in the early 2000s, coinciding with the use of LEDs in airfield lighting. Prior to the use of LEDs, solar power supplies are not a viable power supply due to the high demands of incandescent light fixtures. The first companies to develop solar aviation lighting were Carmana and Avlite. First products to use solar were low-intensity barricade and taxiway lights. As LED technology advanced, ICAO and FAA medium-intensity photometric compliance became achievable around 2008. Today, most airfield lighting applications can be solarized: PAPI, reels, ODALs, simple approach systems, signs, elevated runway guard lights. When you think about the PAPI putting out 30,000 candela in a solar situation, this is a reality. They're installed in many places around the world by many manufacturers. Early types of solar modules were expensive. They had low efficiencies, quality and performance issues with the lamination. There was a silicon shortage from 2004 to 2007, which caused supply issues and cost increases. But with recent deflation of solar module pricing, their use in products such as aviation lighting makes them an overall cost-effective solution. Solar lighting manufacturers have a heightened focus on power conservation. Through electronic management and optical efficiency, we achieve optimal performance. Quiescent current management methods are used. Microsoft processor deep sleep modes when fixtures in standby. Sleep-wake cycling for communication modules. For conventional lighting, power optimization equates to lower operating power. But for solar lighting, it equates to lower operating power plus longer autonomy, increased intensities, or smaller fixtures. DC to DC converters are used to maintain constant current across LEDs with depleting battery voltage. We're in an industry, when we've been talking about it all week, where compliance is extremely important, and is no different for solar aviation lighting. So we maintain that photometric compliance using the DC to DC converter over the operational range of the battery. Advancements. With more than $250 billion in sales last year, the LED industry is still growing. Growth drives innovation, leading to dramatic improvements in the performance of LED technology. Groundbreaking performance records are being reported constantly. We've seen since the beginning with even aviation lighting, we've moved from dual inline packages to surface-mounted devices. Now we have chip on board and multiple chip on board LEDs. As these advancements are made, solar aviation lights gain intensity, become smaller, and their autonomy increases. In 1970, one LED chip produced 1/100th of a lumen. Today, the LED chips used in solar aviation can produce in excess of 100 lumens. Battery and solar panel technology advancements are not quite as fast as LED, but they still are happening. There's some new exciting materials, 2D materials like graphene. This will make it have a great impact probably in all areas of our life, but especially in solar aviation, which will lead to longer batteries and more efficient solar panels. It will also help to change the face of what these solar aviation lights look like, and potentially make it possible to have self-contained inset solar aviation lights. Control and monitoring. Bidirectional wireless communication between light and remote control unit to support control and monitoring is a near-term fact or is already happening in some cases. This allows us not only to control the solar aviation lights, but to actually get their individual status back and report them to operational maintenance people. Redundant communications links exist to ensure if there's a primary failure, there's a backup mode. Integration into existing and new control systems for transparent operation by ATC exists. So we all know that air traffic controllers do not want to operate two interfaces for the airfield lighting. In most cases, there's no real estate available in the air traffic control tower. These lights can be seamlessly integrated with existing traditional airfield lighting. Maintenance reporting to understand the individual light status and any warnings or alarms. So individually, we can report back the battery voltage for proactive battery management, current draw, intensity, the mode of the light, and because of marine, there's an ability to put GPS in these lights. We're using them already for obstruction to ensure that the obstruction lights flash together. In marine, though, they use them to indicate off station where a buoy is broken loose from its mooring. In remote areas, solar aviation can have a challenge with theft. So this could be used to report when the theft occurs and also allow it to track the asset after the theft. It also allows for synchronization of lights. Barricade lights at airports can be very confusing to pilots because they're not flashing together. This technology can be used to have solar aviation barricade lights that are synchronized, providing a consistent message. Mixing solar and traditional lighting frees space in the electrical vault and reduces the load on generators. Simply changing out, or in a project where there's expansion and taxiway edge lights are required, the use of solar taxiway edge lights can reduce the amount of CCRs required in the electrical vault, reduce the amount of circuits that need to be maintained. And as you can see in these pictures, we've all been in a lot of electrical vaults. Many of them are very crowded because it's expensive to expand a vault. It's expensive to build a new vault. So CCRs are put in wherever they can fit until there's no more room. By using even solar aviation lighting for taxiway edge lights, this helps create more real estate in the electrical vault and can eliminate the need for a larger generator, an expansion, or a new entire vault during project modifications. I'm now going to hand it over to Jason. Thank you.
Thank you, Tara. I'm going to speak to some applications and where solar's airfield lighting technology is currently being used, and also some case studies where it might be beneficial to use in the future. Solar airfield lighting technology is currently used by militaries around the world, including the US DoD, in temporary applications. It's also used by commercial airports, permanent overseas, as well as temporary here in the US. Remote airfields can utilize solar airfield lighting when they don't have access to grid power, or it's not cost effective for them to install a traditional wired system. And we're all aware of FAA Engineering Brief 76D, which allows the use of solar for obstruction lighting in many parts of the globe, including the US. Like I mentioned, the US military is a big proponent and user of solar airfield lighting technology. One example is the US Army MOX program, or Mobile Tower System. It's a rapidly deployable system that includes a mobile tower for air traffic control, applications such as disaster response, like we saw in Haiti. They can quickly set up an airfield with no access to grid power, or set up a runway where there was none the day before. For domestic applications, it could be forest fire fighting, and we also see them in theater for deployed operations. Quickly set up an airfield within hours with a mobile control system, the weather monitoring, and the lights are wirelessly controlled from the tower. There's also a covert and overt operation. That system, completed in 2013, included 15 systems with Runway Edge and LZ for helicopter lighting. Like I said, it was controlled by the tower via wireless control, completely independent solar. The biggest part of this mobile tower system was the certifications. There was LH61E certification and LH61 certification for the photometrics of all the runway fixtures. That's what we're talking. When we're talking solar, we're not talking low intensity systems, we're talking compliant systems. We don't yet have certification because there's not a pathway there. Another application could be a permanent airfield lighting system like we saw in the Bahamas. As a result of a new decree from the Bahamas Civil Aviation Directorate, all island resorts had to have 24/7 access to the airports, either for disasters or medical evacuation. Solar made sense for them because it could be installed in less than 3 weeks' time, low investment, low maintenance, in places where grid reliability and grid costs are an important factor when where they can install airfield lighting. That system was pilot activated or could be used by a ground-based controller, all wireless, all independent solar lights. System was completed in August 2012, and like I said, was installed and commissioned in less than 3 weeks' time. Great team put that together. Compliant runway edge system, threshold, taxiway, and as Tara mentioned, a solar-powered PAPI, an independent solar-powered PAPI with FAA certification. That's a permanent system still in use today. It was easy and quick to install, and as I mentioned, maintenance can be an issue in some of these areas without the technical know-how for a wired system. Another application we've seen here in the US is the conversion from runway to temporary taxiway. At a busy international airport on the West Coast, a parallel taxiway had a part of the runway converted to temporary taxiway. Solar compliant taxiway lighting was used to safely and efficiently get the aircraft off the runway and into the taxiway environment. It saved project costs, allowed project flexibility, and was installed in less than a couple days. Again, compliance, a solar compliant solution. That system used L861T certified photometric fixtures. It was easy to install, and a simple dusk-to-dawn operation was used. No control interface was required. The lights simply turned on via internal photocell at night, turned off and charged during the day. And the biggest thing is the autonomy. Another widely accepted use of solar is for obstruction lighting. During hangar demolition at another busy airport on the East Coast, during some runway safety area improvements, because of the proximity of aircraft operations to the exclusion zone, they had to put up a temporary chain link fence. Because of the proximity, the FAA required a certified lighting system on that fence. The contractor decided to go with the solar route to save money and to quickly set up the system, which lowered project costs and allowed a shorter construction period. Those were certified LA10 lights, 26 units in single and dual configurations with the associated power supply for the necessary engineering brief 76D autonomy. Again, a dusk till dawn system, no control interface required, and after the construction period ended, the lights could be used for another project or put out permanently in the field. I'd like to talk about some case studies and looking for feedback. The two airports I chose, Arlington, Washington Airport and Provincetown, chose those because they've either had projects in the past or have a project coming up in the near future. I also have relationships with both, and they gave me the data I was looking for. At Arlington Municipal, they did a 2014 parallel taxiway project for the only lit runway. Included 253 traditional L861T LED lights, 22 L858 signs. The project required 28,000 linear feet of series circuit cable, 13,000 feet of PVC conduit, and 1,000 linear feet of directional drilling. It was a 120-day construction period that required multiple taxiway closures and included some runway back taxi operations. At an uncontrolled field, those can be somewhat dangerous if people are expecting a quick exit when you're on final and then you're having another plane come right back at you. The total cost of that project was $1,082,000 with a share of AIP $974,000. The project scope you can see on the map was the entire parallel taxiway and the 4 runway exits, 253 lights, like I said, and 22 signs. Our contention is a solar taxiway solution, just the taxiway lights, could have saved a significant amount of money on the project and redirected funds to other parts of the airport, which I'll get into shortly. The construction period. 250 plus lights could be installed by 2 people in 1 to 2 days with a lighting layout from our engineering team. The system can integrate seamlessly into the existing control system. At Arlington, they do have a POUT system to turn on the Mausers. So what we're talking about is lowering the project costs, redirecting money, keeping the construction periods lower. What that can allow is other projects on the airfield. There are always considerations made to what part of the airport lighting comes to. Our contention is that runway lighting for a crosswind runway is more important than a parallel taxiway. There's many reasons for this, in my opinion. The crosswind runway increases access, increases safety, and allows operators to use, allows airport users to use both runways at the same time in a safe manner. There are plans for the taxiway parallel to runway 1129 to be lit in 2017. We believe that if a solar solution was used, a low-cost, low-impact solar solution, compliant system was used on that taxiway, that those funds could be redirected to lighting runway 1129, increasing safety, increasing access for a busy general aviation airfield. The next project, I have relationships with the Jacobson Airport Planning Team, is a current airport master plan update at Provincetown Municipal in Cape Cod, Massachusetts. Currently, the parallel taxiway is unlit. They use reflective markers. They're unevenly spaced and not very useful to pilots because they're so far off the center line of the taxiway. Provincetown is served by Park 121 Cape Air with daily activities and low visibility conditions. We believe that Provincetown deserves taxiway lighting. Does it make sense in a funding situation where there's not a lot of funds to go around to put in a $500,000 or $1 million taxiway system? Maybe not. But if you use a solar solution, save money, those funds could be redirected to other airports or even at Provincetown, extending the runway, adding approaches, precision approaches, GPS approaches, LNAV approaches. I'm now going to pass along to Jeffrey, who's going to talk about adoption.
We just talked about how some of these solar aviation airfields have been adopted over the past few years. As Jason mentioned, one of the very earliest adopters of these systems have been military forces, U.S. military, NATO forces, as well as other foreign militaries. The requirements were to have systems that were rugged and reliable, and that could be then deployed to remote locations, that it can be then set up rapidly. These locations generally had no infrastructure available for them. So by having a system that was solar powered, it negated the need for any type of generators or the transportation of hazardous fuels. Besides the military, many sites, remote locations are either underserved or not served at all because of lack of airfields. these type of situations saw the same benefits as the military. By being able to have a system that could be easily installed, they were able to bring life-saving services to many remote villages throughout the world. Currently, the military still remains one of the largest users of solar airfield lighting. Many of them are starting to convert temporary systems over to permanent ones. Here in the US, they are still used on a temporary basis, but for training purposes, but in places where they have expeditionary forces throughout Afghanistan, Iraq, the Middle East, those have been converted to permanent installations. Many other foreign militaries have already set up permanent solar solutions. Regional and international airports here in the US, we're starting to see a lot more favorability for use of solar systems, especially when doing construction work. The use of a temporary system that can be set out quickly and then reallocated to other locations. Therefore, an asset is able to be used more than once without having to deal with wires or difficult maintenance issues. We see that in international airports in foreign countries, many of them use a permanent compliant solution for airfield lighting. GA and private airfields, where the benefit they're seeing is solutions that can be purchased inexpensively, and the cost to own and operate such systems are very affordable compared to having to try and install a wired system. And the exciting news, so to speak, for the solar aviation world is in Brazil. ANAC, their certifying authority there, has finally codified exactly what LED lighting for solar aviation is. For airports operating under VFR requirements, solar LED lighting can be used as primary lighting systems. For airports operating under ILS, they're allowed to be a permanent backup lighting system. Where we see the future going towards here in the US for solar aviation lighting is for non-precision airports. The ability to have a complete, permanent, and compliant lighting system. This would be taxiways, runway lighting, PAPIs, cone lights. Many of these lights already exist today in compliant designs, but there is no path forward available at this time to certify these lights. Where we'd like to see it start here in the US would be to start with the inclusion of a permanent solar taxiway solutions. As we've mentioned before, what these would allow for is to be able to free up cost and funding for other projects so that design and application budgets can be stretched further within those airports. In conclusion, as I said, solar does not equate to non-compliance. The product compliance exists, but the standards lack the path to certification. Many of the lights are already compliant, but by definition within the AC, the fact that they are not wired or operate on 6.6 amps says they're not certifiable. At this time, what we would like to see is the FAA be able to grant waivers to airports to be able to start to include solar solutions, and that at the next revision of the AC, that they would be given due course and allocation within the AC for application. Solar is not an isolated standalone system. The components can be integrated and work seamlessly within traditional systems. Solar lights can be then transparently added to existing systems and tied into the regular infrastructure, and therefore would not add any further work burden upon air traffic controllers. The mix of solar and wired systems lowers the overall total cost of ownership, allowing funding to go further and support more projects. In an environment where we see ever-tightening federal budgets and airport operational budgets, this becomes even more important. And as Ken Green from DIA stated yesterday, the airports are looking for companies to come forward with technologies that will help them save money and be able to do more. We believe that solar solution would be one of those types of answers. Thank you.